Hi friends, myself Dyson. Today we are going to discuss some basic concepts in control systems. First of all, I will tell about the transfer function. Transfer function is nothing but it is defined as the ratio of the Laplace transform of the output to the Laplace transform of the input with zero initial conditions. Next, transfer function can be defined in another way. That is, transfer function is defined as the Laplace transform with impulse response. Next, I will tell about the transfer function is mainly applicable for linear time invariant system. Next, I will say about what is my linear. Linear is nothing but it should satisfy the homogeneity and additivity property. A system is said to be linear, it should satisfy additivity and homogeneity. That is termed as superposition theorem. Next, I will tell about the Mason gain formula. C by R equal to 1 by del summation k equal to 1 to n pk del k. Next, I will tell about time domain analysis. In the time domain analysis, for second order system, the transfer function is C of s by R of s equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square, where omega n is the natural frequency and tau is the zeta is the damping ratio. Next, I will discuss about um, undamped system, underdamped system, critical damped system, and overdamped system based on the damping ratio. For undamped system, damping ratio is 0. For underdamped system, damping ratio is 0 to 1. For critical damped system, damping ratio is equal to 1. For overdamped system, damping ratio is 0 to 1. So, after that, I will tell about root locus. Root locus is nothing but it is the locus of the roots of the characteristic equation as the gain k vary from 0 to infinity. Next, I will discuss about it should in the root locus the starting point of root locus is pole and ending point of root locus is 0. Next, I will tell about steady state error. Steady state error E is equal to limit s and 0 s into r of s divided by 1 plus g of s h of s. Here, in the steady state error, there are three error coefficients: Kp, positional error coefficient, velocity error coefficient, and acceleration error coefficient. Positional error coefficient Kp equal to limit s and 0 g of s h of s. Velocity error coefficient Kv equal to limit s and 0 s into g of s h of s. And acceleration error coefficient Kv equal to limit s and 0 s square into g of s h of s. Okay. Thank you, friends.